Today we're going to talk about some piecewise functions called step functions. Their graphs look like the steps of a staircase. One step function is the greatest integer function. F of x equals x inside these double brackets. And the greatest integer function just says we want the greatest integer not greater than x. So for example, the greatest integer of 8.9 would be 8, because 8 is the greatest integer not greater than 8.9. The greatest integer of negative 3.9 is negative 4, because negative 4 is the greatest integer not greater than negative 3.9. Now sometimes this can get really confusing, so what we can do is think about this. When you're asked to find the greatest integer, think about the number that is to the left of that number on the number line. Think about the integer immediately to the left to that number on the number line, and that'll be your greatest integer. Now the only exception would be, of course, if you're looking for the greatest integer of an integer, it would then be that integer. So for example, the greatest integer of 1.2 would be 1, because 1 is to the left of 1.2 on a number line. The greatest integer of 4.2 would be 4, because 4 is to the left of 4.2 on the number line. The greatest integer of 5 would just be 5, because 5 is an integer. The greatest integer of negative 9.8 would be a negative 10, because negative 10 is to the left of negative 9.8. So when looking for a greatest integer, think about the integer that is to the left of that number on the number line, and you'll be able to find it. Let's go ahead and look at how to graph them. Now remember, these are step functions, so our graph should look like a set of stairs. When we graph an greatest integer function, our domain will be in intervals for which the greatest integer will be evaluated. So when I set it up as intervals. So instead of having just a 1, 2, or a 3, I've got intervals going on here. Now the greatest integer is always going to be the integer that is to the left of a number on number line. So if you'll notice the way that I set these up, the left-hand side of each one of these intervals has a less than or equal to. So it's going to have a closed dot on the left-hand side, and on the right-hand side, it's just less than. It'll have an open dot. So the right hand will be closed, the left hand will be closed, and the right hand will be open. So if we look at the first one, x is between negative 3 and negative 2. Well, when I think about numbers inside this interval, I'm thinking about negative 2.1, negative 2.2. Well, the greatest integer of negative, say, 2.1 would be negative 3, because negative 3 is to the left of negative 2.1 on the number line. If I look at the next interval, it's x between negative 1 and negative 2. I think about numbers like negative 1.5, negative 1.8. Well, the greatest integer of those numbers would be negative 2. So it's always going to be the one that's on the left-hand side. So when I set my intervals up, all I have to do is look at the number on the left-hand side, and that'll tell me what's going to come out of this function. So here, x between negative 1 and 0, the greatest integer is going to be negative 1. Here it's going to be 0, 1, 2, 3, and 4. I'm just looking at the left-hand side, so the integers on the left-hand side will tell me the answers. When I get ready to graph, we're only going to graph a few of these, just so that you get an idea. I'll look at my interval. This is negative 3 and negative 2. So starting on the left-hand side, it's the negative 3, and negative 3 comes out. I use a closed dot, so I go down to negative 3, negative 3. And then here on the right-hand side, I've got a negative 2. Now it goes up to negative 2, but not including negative 2. So I use an open circle at negative 2, negative 3, and that'll be the first step in my staircase. When I connect the dots, I'm just going to use a line segment, because something happens when I jump to the next interval. And when I look at x between negative 2 and negative 1, if I include negative 2, the greatest integer is not negative 3, it's negative 2. So I've got negative 2 at a closed dot. And then if I look at negative, it goes all the way up to negative 1, I'll have a negative 2. So I use an open dot at negative 1, negative 2. So when I get as close to negative 1 as I can, but not right at negative 1, the answer is still negative 2. So I connect the dots, just like that. Oops, I forgot to connect these. Let me go ahead and connect these two right down here. Okay, and then let's look at the third one. X between negative 1 and 0. When I get to negative 1, the output's going to be negative 1, so I use a closed dot at negative 1, negative 1. It goes all the way up to 0, but not including 0. The answer is still negative 1, so an open dot at 0, negative 1. And then I can connect those dots, and I'll have the next step in my staircase. Let's do one more just so you can kind of see. Let's look at this last one. X is between 0 and 1. If I get all the way to 0, the output would be 0, so I have a closed dot at 0, and it'll stay 0 until I get really close to 1, and when it gets to there, it's going to be 0 still, so I have an open circle at 1, 0. So as you can see the pattern here, I'm going to create a set of stairs. I'm going to keep going up. It's going to be closed on the left-hand side and opened on the right-hand side. So it will remain at the left-hand bound till it gets to the right-hand side, and then it's going to jump back up when it gets there. So you would continue this pattern all the way up. Let's go ahead and look at one more example. Here I'm finding the greatest integer, and then I'm adding 1 to it. Again, your domain will be intervals, and we're going to set them up the same way, where we have it including the left-hand side and leaving the other one excluded. So we say x is between -3 and -2, but we're going to include the -3. X is between -2 and -1, we include the -2. X between -1 and 0, and we include the -1, and so on. So what we do up here is we're going to find the greatest integer, then add 1 to it. So if I look at my interval, I know the left-hand bound is the greatest integer, so I just take the number on the left-hand bound and I add 1 to it for each one of these. So -3, I add 1 to that, I get -2. -2, I add 1 to that, I get -1. -1, I add 1 to that, I get 0. 0, I add 1 to that, I get 1. 1, I add 1 to that, I get 2, and then 3, 4, and 5, just like that. So on the interval between -3 and -2, my output's a -2. On the interval between -2 and -1, my output's -1. So this is working just the same as the previous example, except now I'm adding 1 to it. So we'll graph just a few of these. Here it begins at -3, including -3, it goes to -2. So I've got -3 down to -2 with a closed dot. And then at -2, it goes all the way up to -2, but not including -2. The answer is still a -2, so I have an open dot. And I go ahead and connect my dots and have my staircase. Then I go to the next one. At -2, the output is -1. So -2, -1, and it will stay that way until it gets close to -1. So the last point is -1, -1, and I do have an open circle. And then I want to connect those dots. And then we'll do one more. Here at -1, when I reach -1, the output is going to be 0. So I have a closed dot there. And then it's going to be stay 0 until it gets close to 0. So I have an open circle at 0. And then I can connect those dots. And then if I continue the pattern, you're going to find that you have a set of steps going up a staircase. And so we have our step function. So go back, look over this and study it, and see what kind of questions you have. And I will see you in class.